Hi guys, welcome to DNCL Technologies. Today we are going to discuss flyback converter design. How we're going to design these things. So this for structure of this one flyback topology. So we need to use for fuse for production circuit, fuse on MOV, and rectifier circuit we are using for bridge rectifier. Then we are using for snapper circuits for any spike purpose. Next we're coming to pulse transformer, so that pulse transformer we are using for switching purpose. Next we are using for that diode and capacitors for that converting to pure DC voltage and current. And next coming to our feedback circuits, and feedback circuit is provides proper level of voltage and regulate the voltage. So then again to according to the things, it is a duty cycle T on by T on and T off will be working on it. So this for entire circuit of this one play by topology. So coming to fuse, I want to discuss about fuse. So my here this AC voltage, my input voltage, and we have I already assigned a fuse, MOE, bridge rectifier, input capacitor, snapper, transformer design, diode, and output capacitors. Right. So uh, so coming to my fuse circuit, so I can starting discussing for fuse now. So coming to fuse, so fuse we can choose for power. So how much power you are using? So according to only use for two arms fuse or this thing, they have the parameter is a power. Next is a melting point. Melting point means that is you are using material, right? Melting material point. So here we are using for this design. We are using for input voltage. Input voltage we know, I think 185 to 415 volts for DC. This is a DC? No, this is AC voltage 185 to 415 AC. So right, so this input voltage means okay. AC voltage we can't say how much amps coming exactly. So we are using for the according to power, we are using for 2 amps fuse we are using. So this input voltage voltage requirements, and this for you want to choose fuse means like that point you want to follow power and the melting point of material. Okay na, compared to you are choosing DC maybe 10 amps, also you have to choose here only for 2 ampere only, 2 amps only fuse. Okay na, it's fine, understood. And next we are coming to MOE. What is MOE, how it is work? MOE is a metal oxide various stuff, right? This is for MOE. So what it is working MOE, right? So already we are explained clearly, I think the circuits what it is happened, you know, right? So so it's before I'm talking that one, we are this for resistance, this for voltage. So the curve will be like that. When your voltage will be increase, right, automatically our resistance value will be decrease. So like that only working, right? Understood. So before moving is working principle. So how it is means, so when it is coming AC voltage like this much means maybe it is going for behind this voltage means it will be short circuit, it will work for this range only. You won't allow for bridge rectifier. So this like that only working for MOE. Maybe behind, maybe this before we are going to MOE, we have some parameter for continuous voltage or rated voltage. Next one is we can call the surge current. Next one is we can't call as clamping voltage. Next one is response time. Next one is breakdown voltage. So example, okay na. So my continuous rated voltage will be 415 or 285 will be there means, or 415 means 420 will be work. After that 480 will coming means will be breakdown. It will be short circuits. You won't allow. It allow only for up to this range only, the input range will work. Understood? And the surge current we need to choose maybe 2 amps or 5 amps or 8 amps according to your design. So this like that only you have to choose for this one MOE parameters. So we need to choose for MOE maybe how much you need. Some people is tell for different things, MOE or 8 mm or 14 mm 20 mm. So this parameter is important for choosing the MOE. So next coming to bridge rectifier. This for AC to DC conversions convert, but should become voltage will be like that sinusoidal waveform. This one cycle, right? So it will be convert for pulsating voltage, right? So these have different voltage level. It work for some. So this one I mentioned is this. I think this I don't have polarity for AC signal. It will work for the maybe there will be to forward bias and reverse bias working. So due to only forward bias means so will come this way. So here you can make it as one load resistor. So will come this way to. So here not right, this is for DC, right? DC minus, so it will come here. So like that, again like that, again it will come this way will work. One more thing, so this one, right? So this will come this side. You have to do it again. One more thing, the reverse bias we can't go this one again, go this one again. This is for electron flow up will work for bridge rectifier. So bridge rectifier is my input voltage is like 230 means into root 2. Root 2 value is 14414. You calculate means 310.1 volt will come for after bridge rectifier. Where you are probing any scope here means will come that voltage for 310.8 voltage pulsating voltage will come. Understood? And next coming to my